if we looked at this along these letters here, if I were to label the degrees, okay, point A falls at 0 degrees. If my initial and terminal side are the same thing, it's 0 degree rotation. I haven't moved anything. Okay, if I move up to B, B is a 30 degree angle. If I go every 30 degrees, then D would be the next 30 degrees. E would be the next 30. F the next 30. H the next 30. I the next 30. J the next 30. L the next 30. M the next 30. N the next 30. P the next 30. And then the final 30 would be 360. Back to that full rotation. It has the same terminal and same initial and terminal side, right, but it's one full rotation. Okay, the only ones that are missing here are every 45 degrees. So this is 45 plus another 45 is 90 plus another 45 plus another 45 plus another 45 plus another 45 and then the final 45. And so one of the things that you are going to have to do without using notes is you're going to have to be able to fill in all the locations of these angle measures on a unit circle. And so these are the common special angles that you have to be familiar with. Okay, like I said, you should be able to generate these on your own just by doing what I just did. Count by 30s, then count by 45s to fill in anything else. Okay, now, what sometimes is harder to do is to count by radians. Okay, and so before we talk about the specifics of converting into radians, I want to just look at it in terms of what we saw here. In this full rotation is 2 pi for that 360. So in terms of radians, my A point is both 0 radians and it's one full rotation, which if it has a radius of 1, what is that full rotation again? 2 pi, right? Now, when you work with radians, which is going to be, how many of you have done have any of you been exposed to radians before? Okay. So when you work in radians, you're working in fractions of a radian, or of a pi for the most part. Okay, so when you look at this, if we break this full rotation of 2 pi into pieces, let's cut it in half. So what would half of 2 pi be? Okay, so what you know then is 180 degrees is equivalent to pi radians. Okay, we simply took our rotation of 2 pi, cut it in half. What if we take our rotation of pi now and cut that in half? Where would we wind up? So half of pi, or pi over 2, is 90 degrees. Okay, so every 90 degrees is just counting by pi over 2. So if you look at this, you have 0, you have 1 pi over 2, 2 pi over 2. So what would the next one be? 3 pi over 2, and then the next one would be 4 pi over 2, which reduces to 2 pi. Okay, and if we continue to do that, what if we cut pi over 2 in half? What if we split 90 in half? We'd get to the 45. So what's half of pi over 2? Pi over 4. Okay, and so what if we went back to our unit circle here and we just started counting by pi over 4s, okay, like we did with the 45s earlier. So if we go 1 pi over 4, 2 pi over 4, this would be 3 pi over 4, 4 pi over 4. This would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So notice, I mean, we're repeating some of them. I'm just showing you this to help derive it when the time comes. All right, so let's go back and look at the pieces that we have to fill in are every 30 degrees. Okay, well, again, going back to fractions of the whole, if we know that 180 degrees is pi, 30 is what fraction of 180 degrees? 30 over 180 is 1/6, right? So what that means is that every 30 degree rotation is 1/6 of the pi, rotation of pi for radians. So what I can do here is I can call this pi over 6. The next one would be 2 pi over 6, but what does 2 pi over 6 reduce to? Pi over 3. Then I go to 3 pi over 6. What does 3 pi over 6 reduces to? Okay, then I can go to 4 pi over 6. 4 pi over 6 reduces to 2 pi over 3. And then I can keep counting by pi over 6. So this was 4 pi over 6. This is 5 pi over 6. So I want you to fill in the remaining ones with your fractions of pi, please. Pi was 6 pi over 6. So this becomes 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6. 10 pi over 6, which reduces to 5 pi over 3. 11 pi over 6. 12 pi over 6. So one of the things that